On the ground in front of me is a classic 1970s design. This is a freewheel type hub with an axle and a cone and cup type bearing. In this video I'll show you how this cone and cup type bearing, which involves the use of these loose bearing balls, all fit together. I'm going to take it apart, I'm going to put it back together, I'm going to lubricate it as I put it together. We'll explain how the parts fit together and how the geometry works, and we'll show you the components that are involved. It's not rocket science, it's very straightforward. Tools needed: one tweezer that you like, and of course you need the bearing balls, nice and clean. In this case I have a replacement axle that I'm using because the original one is bent. The replacement axle, which is there already, is an alloy steel one. This is how it comes. This is chrome molybdenum alloy steel upgraded axle. The original one, which is bent, is medium carbon steel. Alloy steel is stronger. Its length is 137 millimeters. That's a fixed item, and it has to be threaded, a thread cut into it. Its nominal thread pitch is 10 by 1, so the 10 millimeter nominal diameter, and 1 millimeter is the distance between, that's the thread pitch, the distance between the from thread crest to crest, or root to root, whatever. So this is the specs for this particular axle's thread pitch. This thread pitch, because the cone and the lock nuts are threaded and I want to reuse them, so that's why the thread pitch has to fit. The old one is bent and I tried to straighten it. It's a piece of glass that I have here. It's not perfect. If I roll it a little bit, you can hear it's not perfect. I tried my best. So far I got with straightening. So I'm going to replace it with a stronger one, like I said. Other than the bearing balls, and which are removed from the bearing now, it's not in it, and the tweezer, all I'm using is a rag for wiping hands and grease. The grease is manufactured by Yamaha, as in piano, motorcycle and marine products, and it's in this pot from the kitchen. Please don't tell my wife that I took this out of the kitchen, okay? So that's what's in it, because the tube in which it came disintegrated, whatever, and I just kept it in this one. So that's Yamalube marine grease. Now that marine grease is not a high precision bearing lubricant, but this isn't a high precision bearing either. This is in this case it's a Suntour freewheel, and that's its hub, and the axle and the bearing are likewise classic. That means it's a crude fit. It doesn't really need Tour de France grade, top of the line bearing lubricant. Okay, so Shimano now in 2019 still uses the same type of cone and cup type bearing that's in some of their expensive top of the line hubs. Instead of using sealed bearings, here is an example of a sealed bearing. The seal has just been removed. The seal is floating in here. These are the seals. So here is just one of them. The seal covers, this is a bearing, the seal covers a side, so this would be a sealed bearing this way, and the sealed bearing uses top of the line race lubricant bearing grease. This one just uses whatever, axle grease. Yamaha Marine Lube it is in this case. So let's start at the beginning here. This is how the bicycle wheel comes out of the bicycle. This is where we start. This is your quick release mechanism here, this cam mechanism. This is how it looks like. You have to take this one out to get to the bearing. So one end, typically this one, comes off really easily, and a spring with it. Don't forget the spring. I'll show you the spring. Don't lose the spring, ideally. So here is one of them. This spring is conical, not comical. Conical, different word, yes? So don't lose the spring. You're gonna be sorry if you do. Put the nut back on. There, put it aside. This has been cleaned up before. That's good. Now, this assembly as is, of course, is like this. It's missing the rolling elements, the bearing balls that have been removed and cleaned, and it's ready for reassembly. So that's why this looks like this. However, I do want to point out that here I have about 6 mm of axle length exposed. Same for the other side. You're going to have to set this distance before you take the axle apart when you put it together. For now, just put on a 17 mm wrench on one side and a 17 mm wrench on the other side, and rotate the two lock nuts. I'll show you the two lock nuts. Counterclockwise, one of them will come off. In this case, I'm going to take off this side. Once that's off, the cone comes out. I'll show you in a minute how the cone and the cups and the bearings work together, and where the cups are and whatever. So the cone needs a 15 mm wrench. The lock nut needs a 17 typically. So at this point the axle comes out, and if you have the bearing balls in it, they fall on the ground every which direction, bouncing everywhere. So how you catch them? With a cookie tray, whatever. It's figure it out. You're a big boy / big girl. This is how the cone looks like. And the cone has this curved surface here. This is where the bearing balls are gonna be located. Let me just pull out one of them. They will be rolling like so. I want to show you that the curvature of the ball does not match the curvature of the cone. It should not. They should just touch there at one tiny point, just like so. Just like there. You can see this shiny surface on the cone. Now the cones do wear away. Cones are replaceable, bearing balls are replaceable. This is where the wear happens. So you should be looking at this surface on the cone to see if it's any good or bad, or if it's pitted or gouged out or whatever. This is as good as it gets. I'm not going to replace it. This is a classic bicycle with a classic bearing. You can see some surface imperfection there. That's gonna slow me down significantly, or whoever is pedaling. You get the idea. If the cone is rusty on the outside, it doesn't matter. If the cone is rusty here, it's irrelevant. If the threads are rusted, just run a tap through it and chase the thread. It's not important. What's important for rolling resistance is here. This is the critical surface, or the wear surface, and minor imperfections I'm not really concerned with. So this is how the two of them interact inside the cup. I'll show you the cup, but I don't want to lose this thing, so going back into the pill box. The assembly note. The lock nut in this case has a smooth surface and one that isn't, like it has a lip on it or whatever, textured. The smooth surface goes against the cone like this, and if I'm not mistaken, there used to be a spacer. Yeah, this one used to be inside with, sorry about this, two sides flat on this one. Both of them are flat, so technically this goes in and then the lock nut goes on top of it. I think that's how this side used to be. I'm just going to put them like all in the pillbox. The same of course applies to the other side, but on the other side you have the cone, you have a spacer. This one came with this 1mm or so washer, which is rusty. Like I said, I really don't care, because this is the critical surface here, and this is the lock nut. The lock nut is rotated the same way with this raised surface on it, whatever, facing outside the frame of the bicycle. So this is where the frame goes, and this is where the frame goes. The 15mm wrench goes on the cone, and the 17mm wrench goes on the lock nut. You're gonna have to counter rotate these two of them to tighten up this assembly at the correct distance away from the axles, and this is how assembly begins. Because once they are inside, good luck reaching the cone now. You can't, it's not possible. So that's why you're gonna have to tighten the cone with this lock nut, 15mm, 17mm, counter rotate the two of them, and it gets tightened. Let me show you where the cup is now. I'm gonna put it on the ground here, wipe my hand for a sec, and on a second wheel that I have here, I can show you the cup. So the same freewheel, but I took off the lock ring from the freewheel, so it just comes off like so. And this is the freewheel's hub. Because I loosened this, and it also has a bunch of bearing balls, I can take it off to get to the cup. That's what we're doing. The cup is right here. The bearing balls will sit here on the cup's surface, and the cone is gonna press them against the cup like so. You get the idea. Okay? So the bearing balls will run right where I have the speck of grease. Let me just wipe it out. The bearing balls, you can kind of see where the shiniest surface is in this cup. Let me just get you a nice sharp picture on this. There we go. You can see that the balls roll on this surface here. That's the critical surface. So again, if the edge is rusty for whatever reason, irrelevant. If anything is rusty from here to here, irrelevant. But I will grease it, everything generously, so it possibly doesn't rust. But this is the critical surface for the balls. 9 balls, bearing balls, go on this side, and 9 on the other side. Of course, there's another cup. So cup and cone and bearing ball is how this all fits together. So I'm gonna start on this side for placing the bearing balls in, and because the cone is way underneath the cassette set and the freewheel hub, the cone is, I'm not saying it's not visible from here, but the bearing balls go there. There. It's difficult to see. Alright, but that's what you're looking at, the cup and the shiny, not groove, but the shiny surface on the cup is here. This is where the bearing balls go. If you drop a bearing ball, it's gonna be inside this tube, it's gonna come out on the underside, no big deal. But give yourself some time, and this is gonna be this is gonna need some patience. So how this goes, it's fairly straightforward. I have my pot from the kitchen, and I take one bearing ball at a time. I just pour them all out, but I just deal with one at a time. Press it in grease like so. There. Really generous amount of grease on it, like so. Grab it with the tweezers and put it somewhere there. So now that's in place. but it's difficult to see. Yeah, very nearly completely invisible. That's why I kind of wanted to show you how this is while it's on the outside. So it's right there at the 6 o'clock position, thereabouts. Okay, so that's how it's gonna go. You're working very nearly blind with this thing, but you will be able to see enough because the camera, and I have to tilt up the wheel, whatever. I'm gonna place 9 bearing balls there, and I'm going to take the camera off the tripod because light is different, but the camera will still have a self shadow, so I'm going to put 9 of them there. So that's 1 down. Here is a second one, and now I know this is going to take some of your time, sorry about that. So that's 2 in, and I'm going to work with this wheel while the wheel is kind of upright somewhere. I'm gonna put it there, leave it there. So that's 2 down, and the third one is going in. Now this is not too fascinating to watch, I know, so I'm gonna tell you a little bit about the distance from lock nut on this one, from lock nut to lock nut. Like I said, this may or may not be needed as a space keeper. I think it is. I think it has come out of this hub, and because it's going on the easy side, on the opposite side, it's gonna be easy to add, because from lock nut to lock nut, this assembly has to fit exactly between the frame's components. So if it doesn't, if it's too wobbly, then it needs a spacer like this one, like an 1/8 of an inch, like whatever, 2 millimeters thick, whatever. But that can be added later. Alright, so I have about, I didn't count, but I'm going to move them around a little bit because the cone is oversized, meaning 1, 2, 3, 4, 5, 6 are in, meaning if the bearing balls don't line up precisely, then you can fit more in the same space. So it's not especially tricky, you just have to watch it, that you add exactly 9 and not more. If you have 10, okay, 2 of them fell out. So if you have more than 9 in them, don't worry about it, they will come out, whatever. It's not gonna fit together really well. No, that didn't stay in either. And I dropped that one again. Eventually they are gonna drop out into the grease bucket. Okay, there's one, and there's the other. If this was any significantly faster, I would tell you, but it's really not. It's going like this. Alright, thereabout. I think I have the, oh, yeah, because they don't line up on their own, they need to be lined up. That's why this guy keeps dropping out. I'll get there eventually. There. So that's about 1, 2, 3, 4, 5, 6, 7. Alright. Just 2 more of these. 2 more in the grease bucket. and it slipped out again. I'm not trying to torture you with watching the misery unfold here, but I'm just telling you, you're gonna have to allow enough time for this. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Yeah. So if you need to go to the washroom or whatever, kinda think about it before you start this stuff. There. Now I'm gonna show you how the 9 look like all together. Let's see. I'm gonna wipe my hand because I don't want to transfer the crud to the camera. Get you off the tripod and try to find some good light. So 9 bearing balls. You can kinda see them, all 9 of them kinda glistening in the cup there. What I'm gonna do is I'm gonna put the axle in with the cup on it, and I'm gonna run the cone on the surface like so. This is gonna spread out the grease so they they are more visible. And there, one last look on this thing. Off the tripod. And give me a sec here. Yeah, that's as much light as I can get to it. You kind of see where the bearing balls are, thereabouts, and at the bottom of the cup. Okay, so that's all I see, that's all you see. This is how it goes. Now the other side goes just as painfully as the first one did, but is somewhat easier because the cup is closer here to the surface, and if any bearing balls slide out into the hollow axle here, inside here, that's, yeah, you can see it's dripping out on the other side. I saw one just came out. So if some of them move out, you're gonna have to work with it. You're gonna have to have enough lubricant in it to keep them in place. This is how it goes. And on the other side, one just got misaligned. It's not totally lost, it's still in the same cup space, so this is how it goes. So once I have 2 sets of 9 actually staying in place with the lubricant spread out and whatever, and I'm gonna put extra lubricant on the cone here when it goes in to actually keep everything in place, then it's gonna get tightened from both sides so that it's just good. It's not too tight, it's not binding, but it's rotating nicely and freely without any sideways motion. Okay, so that's how it looks like when it's tightened. That's another video. This is how the components look like, and this is what's involved for the cup and cone and bearing ball assembly.